Hello everyone. This video is about drying of biomass, and in this video I would like to just introduce you to the drying process and how this can be done and why it's important. If you look at this picture here, this is a type of dryer that is used for manure and other wet material, and I will come to this a little bit later. So why biomass drying is important? Because we need to reduce the moisture content of the biomass for a certain level that is actually safe for storage, and at the same time economically visible for transportation and storage. Basically, if you have low moisture content material, it will be easy to handle, easy to transport, and also it may be stored under lower cost compared with material with higher moisture content. The moisture content, as you may know, is the amount of water that is actually contained in the material, and we need to get rid of most of the moisture content until reaching at least equilibrium or until safe conditions for storage. Drying also can increase the calorific value per unit mass. Instead of having wet material with lower calorific value, if we remove the moisture content or the moisture from the material, it becomes drier and it becomes material with higher calorific value per unit mass of the material. If this happens, this can improve the boiler operation if we use the biomass for steam generation, and also it will be more stable material. It will reduce the emission from the material. If it's wet, it will be prone to microbial degradation, and it can emit some of the gases to the environment. So basically, the idea here is to get rid of the moisture for safer and for a condition that not suitable for microorganisms to grow and produce harmful gas to the environment. Of course, if we have lower moisture content in the material, it can be the material will be much biologically stable. This means that it can inhibit molding and other growth of other microorganisms, and therefore it will be more safer for storage. And also it can also prevent the self-ignition. If you are familiar with this process, it can also happen if the material has higher moisture content with the presence of some air. Sometimes if you are driving by some highways, you can see some kind of pile of straw that can catch fire or self-ignition because of the moisture content. Of course, it's also moisture content. Also, if we get rid of the moisture content, it can concentrate the nutrients in the material, and therefore we can use them as much dense fertilizers. For example, if we reduce the moisture content from manure or from biogas effluent, biogas digester effluent, this can condense or increase the concentration of fertilizer per unit mass of the materials. This means that you can actually reduce the cost for transportation, and also you can reduce the amount of materials that need to be applied to the field to provide certain amount of nutrient to the plant. Okay, so here this is the most common method for drying is just a sun drying in the field. For example, here this is example for drying rice straw in the field in California. So the baled rice straw can be stored in this shape here in the left hand side here. You can find this pile pile of baled rice straw, and it can be dry after some days. For example, here you can see how fast this, in this graph here, you can see how fast this material can be dried out. For example, here, this research has been done in 2000, and here they compared the spreading the rice straw and in windrow, and they compared them. So it took something like about 3 days to reduce the moisture content from about 80% moisture content with basis to about 15 to 20%. So this actually is still considered actually as high rate, of course, because under the condition of California is much drier weather and also sunny weather. So basically, this 3 days is good, but it may actually different from this short time to longer time if other states, for example, has different weather conditions. Here, this is another study from Netherlands, and this is just to dry willow also in different depth. They actually simulated some kind of this predicted the moisture content of willow if they put them for some depth. For example, if the willow is piled for 5 meters, it may actually take longer time to dry compared with the thinner depth. So basically here you can have this two curves here, and this is just experiment in the middle here. So it's basically 2.5 meter thick. This basically it can reach maybe about 25% moisture content about in 2 months. However, the more thicker one is still at about 45% or basically kilogram. Sorry, this is kilogram water per kilogram dry matter. So this is as decimal here. It's not really as percentage wise. Okay, and yeah, after that, after some maybe after June, yeah, the predicted is almost like the experimental values, and all of them maybe lower than 30% or sorry 0.3 kilogram of water per kilogram of dry matter. Okay, how important again this moisture content is important if we are going to produce pellets or produce briquettes. So this moisture content need to be reduced from maybe 50 to 80%. Some kind of wood or some kind of energy crops or wood chips need to be dried out to produce moisture content that is suitable for pellets that almost have about 8% moisture content. So again, the moisture content is a factor in pelletization, and of course during the pelletization you may get some kind of evaporation as well. So but in reality you have to reduce the moisture content maybe until 15%, depending on the type of biomass, before using the pelletizer that produce pellets that has about 6 to 8% moisture content with basis. Okay. One of the dryers that are commonly used is a rotary dryer, which is about a cylinder that is rotated, and you can feed the material here, and the hot gas can be injected with the material, and due to this kind of rotary movement, the material can move to the other end. It will be a dry material that can be separated by cyclone, and then you may actually have some kind of dust that is also separated from the material. The retention time in this dryer is about maximum maybe about half an hour inside this rotary dryer. Unlike, of course, the sun drying that takes 3 days, this is only 30 minutes here. the cost of drying about 30% of the billet production cost. So 30% is very significant actually drying, because basically you have to have some kind of energy to be added to the rotary dryer here. Yeah, based on this study here in National Renewable Energy Laboratory in 1998, the billets again consume about 2,800 megajoule per ton of pellets. So it's really time consuming. This is just example for the billet production. Again, this is a rotary dryer again here. This is for manure drying in Wisconsin, and this company is it called Energy Unlimited, INC, and this big scale, this is industrial scale that can use the wet manure and produce, especially for fibers, to produce easy transferable fiber for other application. You can actually go to learn more about this process in this website here. Another system that can be used also for drying is just the greenhouse dryers. When in this case, we have here a solar greenhouse dryer for biowaste paper blend. So basically, biowaste from municipal solid waste, and it has some paper blend. And here you can actually have some kind of mixing. In this case, it can be a robotic basically here. So basically they design also a robot, maybe this kind of a robot that can go through the material to mix from time to time to expose more of the wet material to the air here. That is, of course, if you know that the greenhouse here just to entrap some of the solar energy, and then they have some kind of fans that move the air from inside to outside, and in this case it can speed up the drying process. And of course, as I mentioned, this kind of mixer or this kind of agitator basically can go and mix the material to speed up the drying. This is very nice system, in fact. Other system maybe also can combine not only just the greenhouse, but also it can also use a solar collector. So basically, to save more energy or more from conventional energy sources, it can actually use a solar collector to have an extra heat to be added to the drying. And in this case, they use this kind of system for drying of sludge and other material, especially with higher moisture content. This is here. This is some kind of rock bed just to store some of the solar energy. As you know, that the duration of solar energy or that it change from time to time over the day. So basically, you need some kind of storage of the heat, especially during the night, to supply more energy to the drying bed here. This is just sludge, and you have some kind of fan again to move the air and to especially the wet air from inside to outside. Again, this is a more efficient system compared with just the greenhouse. And of course, you have some kind of ventilation just to replace the air with the wet air from inside to outside. This is how the dried sludge look like here in this picture. With that, I would like to thank you. And if you have any comment,